Hello friends, let me present an updated video tutorial on installing the Proxmox hypervisor on a mini PC with an Intel processor. After that, we will deploy a virtual machine with Home Assistant OS. This installation method is suitable for almost all modern mini PCs. Their performance is sufficient not only for Home Assistant, but also for running other operating systems or services, for example, as separate containers. The main idea is that Proxmox allows you to use the device's resources efficiently. If one system doesn't require all the available power, the hypervisor distributes resources between several virtual machines, allocating to each exactly what it needs. In addition, Proxmox supports full backups and restoration from them literally in one click. Convenient, fast, and safe. More on all of this below. And before we begin, as usual, please like this video. It helps the YouTube algorithm show it to others who are also interested in smart home topics. And of course, don't forget to subscribe to the channel if you haven't already. There's a lot of interesting and useful content ahead. I'd like to remind you that all the necessary links to resources mentioned in this lesson can be found in the video description. Let's start by downloading the latest Proxmox image from the official website. On the Downloads page, select the latest version. At the time of recording, it's Proxmox VE 9.0.1. Click the Download button to download the ISO installer file. Next, we'll need a USB flash drive onto which we'll write the installer image. For this, it's convenient to use the Balena Etcher program. As always, the link is in the video description. Connect the flash drive to your working computer, launch the program, select the previously downloaded Proxmox file, and click Flash. After selecting the installer file, the process of writing the image to the flash drive will begin. First, the program prepares the device, then performs the write operation, and finally checks the data integrity. This stage will take just a few minutes. While the process is running, a few words about what Proxmox is. It's a powerful open-source hypervisor that allows you to run multiple operating systems or containers on a single device. It's ideal for mini PCs because it enables you to make the most of their resources, for example, running Home Assistant, a media server, and additional services on one platform. After the verification is complete, the flash drive will be ready. You can proceed to install Proxmox on the mini PC. Now disconnect the prepared flash drive from the working computer and plug it into a free USB port of the mini PC where we will install the system. The specific model of mini PC does not matter. This instruction is universal and will suit almost any device that uses an Intel processor. In my case, it's a B-Link mini PC based on the Intel Celeron J4125, a typical option in terms of performance and energy efficiency, perfectly suited for smart home tasks. Next, turn on the mini PC and enter the BIOS menu. To access it, you usually need to press the Delete, F2, or F7 key, depending on the device model. In the Boot section, select Boot from the flash drive that contains the Proxmox installer. In my case, it's the UEFI USB device option, which I set as the first boot priority. After that, save the changes, usually by pressing F4 or selecting Save and Exit. The mini PC will reboot and begin the Proxmox installation from the connected flash drive. After rebooting the mini PC from the flash drive, the Proxmox VE installer start screen will appear. Here, select the first option, Install Proxmox VE Graphical. After the installer starts, the first thing that appears is the license agreement window. Click I agree to proceed to the next installation step. In the next step, select the storage drive where the system will be installed. The installer automatically detects all available drives. Just select the one you plan to install the system on and click Next. At the next stage, the installer will prompt you to select regional settings. Here, specify the country, time zone, and keyboard layout. These parameters are needed for the system to correctly display the date and time and automatically select the nearest update mirrors. In this step, create a password for the root user. This is the main administrative account of the Proxmox system. Below, enter your email address. The next step is to configure the network settings of the future Proxmox server. It's important to enter the correct values here so that you can access the system's web interface after installation. In the Management Interface field, select the network adapter through which the mini PC is connected to the network. Then, set the host name. In my case, it's blink.proxmox. Then enter a static IP address, for example, 192.168.0.51, as well as the gateway and DNS server address. Most often this is your router's address, for example, 192.168.0.1. If the system has multiple network interfaces, it's important to specify a wired connection, usually labeled as IMP1S0 or ETH0. The wireless interface LO1 is not recommended. Proxmox operation over Wi-Fi is unstable, especially when managing virtual machines and backups. Before the installation begins, the installer displays a summary table with the selected settings. Here you can once again make sure everything is correct: drive, country, time zone, network settings, and server address. After confirming the settings, the Proxmox VE installation begins. On the screen, you can see brief information about the platform's capabilities. It supports both full and container virtualization, allows you to manage multiple servers from a single interface, create backups, and even migrate running virtual machines between devices without downtime. Typically, the installation process takes 5 to 10 minutes, after which the mini PC will automatically reboot and load the installed system. After the installation is complete, the system will automatically reboot. System message lines will appear on the screen. This is the normal Linux boot process. Don't forget to go into the BIOS and remove the flash drive from the first boot priority, and then restore SSD as the primary boot device. Save the changes and exit. The system is booting. This is how it looks on the monitor screen. From here, we can work via browser. You need to connect using the address and port shown here. Open a browser on your working computer and go to this address. The browser may show a warning about a potential security threat. This is normal because a self-signed certificate is being used. Click Advanced. After clicking Advanced, an option will appear to proceed to the site despite the warning. Here, select Accept the risk and Continue. This is safe because the connection goes directly to your local Proxmox server and the certificate is self-signed. Browsers don't trust it only for that reason. After confirming the security exception, the Proxmox VE login page will appear. In the username field, enter root. And below, the password you set during installation. Leave the authentication method as Linux PM standard authentication. Choose your preferred interface language and click Login. After logging in, the main window of the Proxmox VE web interface opens. On the left side, you'll see a list of servers and data centers. This is where we'll create and manage virtual machines. On the right, you'll see details of the selected node, CPU load, memory and disk usage, as well as storage status. At the top panel are buttons for starting, rebooting, and creating virtual machines or containers. This is the administrator's main working tool. All resources, network settings, updates, and backups are managed from here. To begin configuring the system and executing commands, let's open the built-in console. To do this, select our server from the list on the left and go to the Shell tab. A terminal will open with root access. From here you can manage the system directly, install packages, and perform any administrative tasks. To simplify the installation process of Home Assistant OS and Proxmox, we'll use a script from the Proxmox VE Helper Scripts project. You'll find the link in the video description. The script page lists the minimum requirements: at least 32 gigabytes of disk space and 4 gigabytes of RAM. Copy the command at the bottom of the page. Return to the Proxmox console in the Shell tab and paste the copied command. Press Enter. After running the script, a confirmation window will appear. The system asks whether to create a new virtual machine for Home Assistant OS. Just select Yes and press Enter. Sometimes, on the first attempt to run the Home Assistant OS installation script, an error message appears. The script couldn't automatically install the PV package, which is required for proper operation of the process. To fix the error, simply follow the recommendation in the message. Enter the suggested command in the console. After running the apt install PV command, the system downloads and installs the missing package from the repository. Once the installation is complete and the command prompt appears again, you can proceed to rerun the Home Assistant OS installation script. After successfully installing the PV package, return to the setup script. Re-enter the same command. Again, a window appears asking whether to create a new Home Assistant OS virtual machine. Confirm the action, select Yes, and the automatic installation process begins. The next step is selecting the virtual machine configuration. You can use the default parameters, but to demonstrate the process in more detail, choose the advanced option. This allows us to manually set the required resources and parameters for the future Home Assistant OS virtual machine. In the following step, the script suggests selecting the version of Home Assistant OS to install. It's recommended to use the stable version. This is the most reliable build for stable system operation. Next, the script prompts you to specify the virtual machine ID. This is a unique number that Proxmox will use to identify the VM. You can leave the default value of 100. Now the script suggests choosing the machine type. For modern systems and mini PCs with UEFI, it's recommended to keep the Q35 option. It supports PCIe devices and provides optimal compatibility with modern hardware. The second option, i440FX, is used only for older systems. Confirm the selection by clicking OK. At this stage, the virtual disk size for Home Assistant OS is set. The default is 32 GB, but I increased it to 64 GB to allow space for future updates, integrations, and backups. The next parameter is disk caching mode. Here I kept the default value. This mode ensures maximum data reliability because writing occurs directly to the disk, bypassing RAM cache. On the next step, you specify the hostname, the name of the virtual machine in the Proxmox system. It will appear in the list of virtual machines and be used for device identification in network settings. At this point, the script prompts you to select the CPU model for the virtual machine. I chose the host option, which uses all features of the host system's processor. This choice ensures maximum performance for Home Assistant, as the VM gets direct access to the real CPU's instructions and optimizations. The default option, KVM64, is better suited for migrating between servers but performs slightly slower. Next, specify how many CPU cores the virtual machine will use. I left the value at 2 cores. This is more than enough for stable operation of Home Assistant and all its integrations. If needed, you can increase the number of cores later in the Proxmox VM settings. The next parameter is the amount of RAM allocated to the virtual machine. I set it to 4096 megabytes, or 4 gigabytes, half of what this mini PC has. This should be sufficient for Home Assistant, and if needed, the memory size can be increased later via the Proxmox interface. At this stage, we specify the network bridge through which the virtual machine will connect to the local network. By default, VMBR0 is used. This is the main bridge created during Proxmox installation and is linked to the mini PC's physical network adapter. Leave VMBR0 as is and confirm the selection by pressing OK. Next, the script prompts you to specify the MAC address of the virtual machine's network interface. By default, it is generated automatically, and in most cases, this is sufficient. You should change it manually only if you need to retain the previous address, for example, after moving the system or for DHCP reservations. The next window prompts you to specify a VLAN ID if your network uses virtual LAN segmentation. In my case, VLAN is not used, so I leave the field empty, as suggested by the script. Next, you can specify the MTU size, the maximum size of a network packet that can be transmitted through the interface. If you don't have specific network requirements, such as jumbo frames, leave the field empty to use the default value, 1500. This option is suitable for most home and office networks. At the final stage, the script asks whether the virtual machine should start immediately after the installation is complete. I leave the option as yes, so that Home Assistant OS starts automatically after creation. After all settings are completed, the script reports that everything is ready to create a virtual machine with Home Assistant OS 16.2. Simply confirm by selecting Yes, and the installation process begins. After confirmation, the script starts creating the virtual machine using the parameters specified earlier. A summary is displayed on the screen. Home Assistant OS version, machine type, disk and memory size, number of cores, network settings, and other selected parameters. Next, Proxmox automatically checks storage availability, downloads the Home Assistant OS 16.2 image from the official source, unpacks it, and imports it into local storage. After the download is complete, the script asks whether to keep the downloaded Home Assistant OS image for future installations. If you plan to deploy Home Assistant again on the same server, you can select Yes. The image will remain cached and won't need to be downloaded again. I choose No to save disk space, since the installation is one time. The installation process completes successfully. The script has sequentially created the virtual machine, imported and attached the disk, added an EFI partition, and then automatically launched Home Assistant OS. At the bottom, you'll see the message, completed successfully, confirming that everything went smoothly. Now the Home Assistant virtual machine is fully operational and appears in the VM list in the Proxmox interface. After launching the virtual machine, a message appears in the console indicating that the system is ready. Home Assistant OS has successfully booted, and we can see that it's already running, with network addresses displayed for accessing the interface. Once the virtual machine is running, open the indicated address in your browser, followed by colon and port number 8123. The Home Assistant setup page begins to load. At this stage, the system installs the required components, downloads updates, and prepares the environment for the first run. This process can take up to 20 minutes, so simply wait for the installation to finish. After that, the initial setup screen will appear. After setup is complete, the system automatically opens the Home Assistant welcome page. Here you're presented with two options. Create a new system from scratch by clicking Create My Smart Home. Restore from a backup, if you previously had Home Assistant configured. Next, the system prompts you to create the first user. Here, I enter the name, username, and set a password for logging into the Home Assistant interface. This account will have administrative rights and will be used for further configuration, adding integrations, and managing devices. In the next step, Home Assistant prompts you to set the geolocation, your home's physical location. This information is used for automated features such as calculating sunrise and sunset times, weather data, or geofencing. You can set the location on the map now or skip this step. The location can always be set or changed later in the Home Assistant interface. Next, the system asks you to specify the country where your home is located. This setting is necessary so Home Assistant can correctly display measurement units, temperature, time format, and other local parameters. At this stage, Home Assistant asks whether to allow the collection of anonymous data to help developers. This includes basic analytics, usage statistics, diagnostic reports, and technical information that helps improve the system and add new features. I recommend enabling all of these options, as the data collected by Home Assistant is fully anonymous and contains no personal information. After the initial setup is complete, Home Assistant automatically scans your local network and displays a list of discovered compatible devices. This may include TVs, media boxes, routers, Zigbee hubs, as well as devices running ESP Home or Matter. After completing the setup, we land on the main Home Assistant interface. Here you'll see all automatically discovered devices and integrations. In my case, it's several WLED controllers and Google Smart Speakers. Back in the Proxmox interface, you can check the status of the running Home Assistant OS virtual machine. On the Summary tab, key parameters are displayed: CPU and RAM usage, allocated disk size, and the IP address through which Home Assistant is accessible. In my case, it shows that the virtual machine is using about 94% of 4 GB RAM, and the CPU load is only a few percent. Further down on the same tab, you'll find graphs for CPU usage and memory consumption by the virtual machine. These graphs make it easy to monitor how the system behaves under load, for example, during updates, automations, or while integrations are running. Below that, you'll see graphs for network activity and disk operations of the virtual machine. At the top, you can monitor incoming and outgoing traffic, such as downloads of Home Assistant updates or integrations. Below, disk read/write statistics, reflecting database and log operations. And here, you'll see charts showing the load on the CPU and disk subsystem. These indicate whether there have been delays in system performance due to lack of processing power or disk throughput. In the System Info section, you can view the current state of all key components of the installed Home Assistant. Core, the main platform engine. Supervisor, handles updates and add-ons. Host, the Home Assistant OS itself. All versions are up to date at the time of recording, and there are no errors or warnings. On this tab, all devices that Home Assistant automatically discovered in your network are shown. In this example, the system found several Xiaomi gateways, ESP Home integrations, Home Connect, and Kintic Gateway. It's important to understand that this list will differ for every user. Home Assistant selects integrations based on the specific devices connected to your network. In the virtual machine settings for Home Assistant OS, you can change the amount of RAM allocated from the mini PC's resources if needed. To do this, open the Hardware tab, select the memory item, and double-click on it. After opening the Memory Edit window, you can set a new RAM size in megabytes. In this example, the value is increased from 4096 MB for gigabytes to 6144 megabytes, 6 gigabytes. Click OK to save the changes. After saving, we can see that the allocated memory has changed. The virtual machine will now use 6 gigabytes instead of 4. However, to apply the change, a reboot is required. For now, we'll make one more change. Let's add a USB Bluetooth adapter, which has significantly better sensitivity than the built-in one. By the way, you can use the same steps to connect a USB Zigbee coordinator if you're integrating sensors or other smart home devices. First, we need to check what USB devices are connected to our mini PC. In the Proxmox console, enter the command susp. The output will show a list of all devices, and among them, you should see the adapter. Once we've confirmed that the adapter is connected and recognized by the system, we can add it to the virtual machine. In Proxmox, go to the Hardware tab, click Add, and select USB device. In the window that appears, select the option Use USB Vendor/Device ID. This allows Proxmox to precisely identify the device to pass through to the virtual machine. From the drop-down list, select our adapter. In this case, CSR8510, a Bluetooth dongle we previously saw in the LSUSB output. After selecting it, click Add to attach the device. Now we see it listed under the virtual machine's hardware. The adapter is now available inside Home Assistant, and the system will be able to use it for working with Bluetooth devices. Now that we've made all the necessary changes, we need to apply them. To do this, click Shutdown Reboot on the top panel. Proxmox will ask for confirmation. Click Yes. After the reboot is complete, we can see that all changes were successfully applied. Now in the memory usage section, it shows that the virtual machine is using 6 gigabytes of RAM instead of 4. Accordingly, instead of 94% usage, it's now just 60%. After restarting Home Assistant, open the Integrations tab, and you'll see that the system has automatically detected a new device, the Bluetooth adapter we just passed through via Proxmox. Once Home Assistant has detected the adapter, a short setup process remains. First, the system prompts you to confirm adding the discovered Bluetooth device. Just click Submit. In the next step, a new device is created, the CSR8510A10 adapter, which will be used for communication with BLE gadgets. After the setup is complete, the device appears on the Bluetooth tab with an active connection status. This means that the USB Bluetooth adapter pass-through was successful, and Home Assistant is now fully ready to work with Bluetooth devices. To ensure Home Assistant always has the same network address, we'll assign it a static IP. In the menu on the left, open Settings System. Next, select the Network section. By default, the mode is Automatic, DHCP. The system receives an IP address automatically, which could change after a reboot. Switch to Static and manually enter the desired IP, subnet mask, gateway, and DNS. In the example, the IP was changed from 192.168.0.246 to a fixed 192.168.0.42. After saving, Home Assistant will always use this address, which is convenient for integrations, port forwarding, and remote access. So, we've completed the entire process. from deploying a virtual machine in Proxmox to fully configuring Home Assistant OS. Along the way, we installed and launched Home Assistant, configured the system's basic settings and anonymous analytics, checked the interface and compatible devices, optimized the virtual machine, increased the RAM allocation, added and passed through a USB Bluetooth dongle via Proxmox. Zigbee coordinators can be added the same way. Confirmed that the adapter is recognized and working in Home Assistant. And finally, assigned a static IP address so the system always remains accessible on the network. That's all. Thanks for watching this guide to the end. I'd really appreciate your likes. They help promote the video on YouTube. Subscribe to the channel so you don't miss new reviews and tutorials. You'll find links to my social media, Telegram channels, and smart home discussion groups in the video description. Join in, it'll be interesting. Thanks again for your attention. See you soon, and peace to everyone.